Topic for the video is multi-agent game-theoretic AI agents and the transformation and efficient management of the world, technologies, algorithms, programming, and profound applications. Introduction. In an era dominated by global complexity, rapid automation, and decentralized decision-making, the integration of intelligent technologies is no longer optional but essential. Two of the most powerful and transformational scientific paradigms in history, game theory and artificial intelligence, are now converging to build a new class of intelligent systems capable of learning, adapting, reasoning strategically, and managing large-scale, interactive environments. These systems, known as multi-agent game-theoretic AI agents, are designed to operate in settings where multiple autonomous actors with distinct objectives interact dynamically. This paradigm is set to redefine how decisions are made and systems are managed across virtually every sector, from governance and security to energy, healthcare, education, and global trade. Their emergence signifies not just a technological evolution but the creation of a strategic decision infrastructure for the entire world. Call to collaboration. As we enter this new era of strategic machine intelligence, we extend an early and urgent invitation to interdisciplinary collaboration. We must co-create an ecosystem where strategic agents work for human progress, resilience, and stability. This is your opportunity to shape a major technological and institutional leap. The strategic significance of game theory. Game theory is the mathematical study of strategy and interaction among rational agents. It provides the core language and logic for understanding how decisions affect and are affected by the actions of others. This field has profoundly impacted economics, political science, evolutionary biology, and now computational systems. It models conflict, cooperation, competition, incentives, and equilibrium behavior, essential features of real-world intelligent systems. Its universal applicability is reflected in the Nobel Prizes awarded to pioneers such as John Nash for equilibrium theory, Thomas Schelling for strategic conflict, Alvin Roth and Lloyd Shapley for matching markets, and Paul Milgram and Robert Wilson for auction design. These contributions extend beyond theory. They have directly shaped organ exchange programs, national security strategies, energy pricing mechanisms, and digital advertising markets. In AI, game theory becomes the bridge between learning and reasoning, between action and anticipation, and between autonomous agents and social outcomes. It enables the construction of systems that are not just adaptive but strategically aligned, robust to manipulation, and capable of equilibrium-seeking behavior in high-stakes environments. The power and architecture of artificial intelligence. Artificial intelligence enables machines to learn from data, interpret environments, act autonomously, and optimize performance over time. Through deep learning, reinforcement learning, probabilistic inference, and symbolic reasoning, AI systems can solve complex problems across diverse domains. However, most traditional AI models are built in single-agent or isolated contexts, where the environment is passive or static. In reality, intelligent agents exist in environments populated by other agents, each with its own goals, information, and strategies. In such settings, naive optimization fails, strategic reasoning is required. Integrating AI with game theory equips agents with the tools to model, predict, and respond to other agents. It transforms AI into a multi-agent, interactive, self-regulating architecture capable of operating in dynamic systems such as global trade networks, autonomous vehicle fleets, distributed energy markets, and cyber defense infrastructures. It also supports the design of learning agents that balance short-term rewards with long-term equilibria and account for feedback loops caused by other strategic entities. Integration of game theory and AI in multi-agent systems. The integrated paradigm of game theory and AI gives rise to multi-agent game-theoretic AI agents, autonomous systems that operate under uncertainty, competition, cooperation, and negotiation. These agents are equipped with strategic learning capabilities, equilibrium reasoning, incentive alignment, and adaptive control in stochastic, partially observable, and dynamically evolving environments. Technologically, they are built on a foundation of algorithms, including multi-agent deep Q learning, policy gradient methods, counterfactual regret minimization, CFR, quantal response equilibrium computation, fictitious play, and Nash-based planning. They utilize libraries and platforms such as OpenSpiel, Petting Zoo, RayRLLIB, and TensorFlow agents for large-scale simulation and deployment. Mechanism design and auction theory provide the backbone for their incentive compatibility, while opponent modeling and Bayesian reasoning support their belief updating and anticipatory adaptation. These systems are essential for managing distributed infrastructure, resolving allocation problems, and coordinating self-interested entities under constraint and risk. They combine the predictive accuracy of learning with the strategic foresight of rational planning, enabling them to function effectively in both cooperative and adversarial multi-agent systems. Applications in global transformation and management, multi-agent game-theoretic AI agents are being deployed across a wide array of global applications that require strategic coordination and adaptive control. In national security, Stackelberg security games and autonomous red teaming allow defenders to predict and preempt adversaries in cybersecurity, border control, and critical infrastructure protection. In healthcare, these agents help model public health policies, optimize pandemic response, and allocate scarce resources such as ICU beds and vaccines through strategic triage and incentive-aligned compliance mechanisms. In energy systems and smart cities, agents coordinate load balancing, traffic control, and demand-side pricing using congestion games and auction-based mechanisms. In finance and digital markets, autonomous agents operate in real-time trading environments, utilize algorithmic pricing, and employ automated negotiation systems, with equilibrium learning guiding their strategies. In climate governance and international diplomacy, agent-based simulations model treaty compliance, coalition dynamics, and emissions trading under global strategic uncertainty. These applications show that strategic AI agents are not futuristic abstractions, but active components in managing critical systems that sustain life, commerce, and peace. Conclusion and strategic outlook: the integration of game theory and artificial intelligence represents one of the most profound technological advancements of our time. By embedding strategic reasoning into intelligent agents, we move beyond automation to create systems that can simulate, negotiate, coordinate, and self-regulate. These multi-agent AI agents are essential for building resilient, fair, and efficient systems in an increasingly decentralized and unpredictable world. Their design and deployment will shape the next generation of infrastructure, from global governance and digital markets to cyber defense and collective intelligence. This is not simply a research opportunity, it is a civilizational imperative. We invite global participation in this effort. Collaborate with us to build simulation platforms, learning algorithms, policy frameworks, and real-world applications. Help us develop strategic intelligence curricula, ethical standards, and interoperable technologies. Subscribe to our platform for deep dive technical content, real-world case studies, and collaborative updates. Contact Professor Dr. Sada M.N. Islam, NAS, to collaborate on industry applications, publications, workshops, open source tools, and joint ventures. Email address is sada.islam@vu.edu.au. Join us in building the strategic operating systems that will transform and manage the world wisely and efficiently. Let's design the future of intelligent decision-making, together.